Hey, to you, welcome back. Is your application bogged down by a flood of requests, or are your users staring at screens while your database struggles to keep up? There is a powerful technique to alleviate this pressure and dramatically improve performance. It's called read replicas or read replication, and it's all about offloading the readers. Okay, let's try to understand the core idea copies for reading that. The core idea behind read replication is simple but quite incredibly effective, especially for applications which with significantly more read operations than write operation. You create one or more copies of your main or primary database. These copies are known as read replicas, while the primary database continue to handle all the write operations. The inserts, the updates, and deletes. The read replicas are dedicated solely to serving read queries. This effectively distributes the read workloads, taking the pressure off your primary database and allowing it to focus on writes. Okay, I said a lot of good words, but we need to understand how it implements. So for this one, we have this small system. We have our app system. We have our primary database, and we have our replicas. Our replicas here serves all read requests from the app. Okay, and we have our primary database. It's handle all the write operation like inserts, update, deletes. And whenever the app writes anything to the primary database is replicated through to our replicas. Okay, so by this, as you can see, first we have we will improve the read performance because it's not one database handling reads. We have two database handling reads. We offload the load on the primary database. We also have some sort of redundancy. So when one replica goes down, there is another one can handle read requests. Even if the primary replica goes down, another replica can takes place. So implementing read replication typically involves a primary replica, which is the setup here. As you can see, your main database is designed as designed as the primary database. This one, it's responsible for all writes operation, as we said. Then one or more read replicas, as you can see here, which are created. Any changes made to the data on the primary database are then replicated to those replicas or copied to them. This replication can happen in two main ways we need to talk about. First, we can do this in asynchronous replication. This is the most common approach when a write occurs on the primary database. It's acknowledged quickly, and the changes are often or are then propagated to the replica in the background. This means there is a slightly delay known as replica lag before the replicas are fully up to date. Next, we have a synchronous replication. In this more stringed approach, a write operation on the primary is only considered successful after it has been committed and confirmed to all the replicas. This ensures a strong consistency but can increase the latency of the write operation. Why? Because when you write something to the primary database, it will not send acknowledgement to the app until it tries to replica 1 and replica 2, and both replica 1 and replica 2 send acknowledgement to the primary replica of the primary database. And once it gets the acknowledgement that everything is all set, it will send it back to the app, and this process takes time. And next we have synchronous replication, and this more sorry, I did talk about it. So to effectively utilize read replicas, your application needs to be configured to send all write operations to the primary database, okay? But route the read queries to one of the available read replicas. This is often achieved using maybe a load balancer, or let's assume that the app is our load balancer here, which will distribute the read traffic evenly across the replicas. Cloud providers make it incredibly easy to set up read replicas and even offer auto-scaling features where the number of read replicas can automatically increase or decrease based on the current read traffic demands. Okay, next we need to talk about when to consider read replication. I would say first you will consider using them in high read traffic, low write traffic. Like this is the sweet spot. The sweet spot. If your application is experience significantly more read operation than write operation, which is common in many web applications, content platform, e-commerce sites, and social media, read replicas can dramatically reduce the load on your primary database. Next, we have improving primary database performance. By offloading read queries, you free up the primary database to handle write operations more effectively or efficiently, improving its overall performance and stability. Next, we have geographically distribute reads. Here you can like strategically place read replicas in different geographic regions closer to the users, reducing latency for read operations in those areas. For example, having a replica in the US for US users and another replica for for Asia for Asian users, for example. And lastly, we have pacing fault tolerance. Like why not all full backup solutions this replica can provide a degree of fault tolerance. If the primary database experience a temporary issue, the replica can potentially continue to serve read replicas, for example. Okay, next we want to talk about limitation and the trade-offs of read replicas. The first thing, and I guess this is the biggest one, it's eventual consistency. As we mentioned earlier, with synchronous replication, there will always be a slightly delay. We call this the replication lag between when a write occurs on the primary and when that change is reflected on the replicas. This means users might occasionally see slightly outdated data on read queries. Your application logic needs to design to handle this eventual consistency. Next, we have write heavy workloads. Read replicas, read replicas, as the name suggests, only help with read traffic. If your application is primarily write intensive, I guess this technique won't provide significant performance improvements to you. Next, we have increased costs, like running multiple database instances. The primary and one or more replicas naturally leads to increased infrastructure and storage costs. Number 4, we have fail over complexity. If the primary database fails, promoting one of the read replicas to become the new primary requires careful management. This approach can involve downtime and potential data loss if not handled correctly. Okay. So let's go to our conclusion. I would say read replica is a powerful and relatively straightforward way to significantly improve the scalability and performance of read-heavy applications. By offloading read traffic to dedicated replicas, you can reduce the load on your primary database and improve responsiveness for your users. Just be mindful of the eventual consistency implications and the increased operational costs. So, have you implemented read replicas in your applications before? What were your experience with read replication lag or failover? Share your insights in the comment section below. If you found this video helpful, please like, subscribe, and hit the notification bell for more deep dives in database scaling techniques. So yeah, thanks for